Welcome to ELV Prasad Tech Zone. Here the topic is Hadoop 1.0 architecture. We had seen in our previous videos Hadoop. Hadoop is a distributed parallel data processing computation framework. It follows master-slave architecture. Here let us see the architecture. Hadoop 1.0 architecture. We have the various components in 1.0 architecture which are name node, and it has a job tracker within that, and a secondary name node. It is a standby of name node, and we have the various data nodes. Within the data nodes we have task tracker. So within the name node we have job tracker which tracks the jobs related to the name node, and task tracker within the data node tracks the task within the data nodes. And here we have seen the secondary name node which acts as a standby node for name node. If any failure in name node, secondary name node will become a name node. It has the same configuration as that of the name node, and based on the configuration time specified, like every hour or 2 hours, the data will be merged into secondary name node from the name node with checkpoints. And we have seen the data nodes, right? So here data nodes follow whatever the name node direct, because Hadoop follows master slave architecture. Here master is the name node and slaves are data nodes. And here in the map reduce job, here map reduce job takes care of data processing as well as the cluster management, in the sense allocation of resources. And data will be stored in the Hadoop 1.0 is in Hadoop distributed file system, that is in HDFS. And here replication factor is 3. It means 3 copies of data will be replicated in various data nodes in the cluster. And maximum nodes supported in Hadoop 1.0 is 4000 data nodes. And default block size, here we have seen, right, the default block size is 64 MB. Here meaning that the data will be partitioned into various data nodes. If the data crosses default block size, then that data will be moved into other partitions. So in this way data will be partitioned. And this and also here we had seen various data nodes with the heartbeat. Actually heartbeat is the data nodes will be monitored by the name node, so to get the status of the data node. So that is the heartbeat of various data nodes that will be maintained by name node. And within the name node and second node we had seen fs image and edit log, right, which are stored in RAM as well as the hard disk. Actually here fs image, it has the snapshot of HDFS namespace at a given point in time. So fs image is a file stored in the OS file system which has the complete directory structure of HDFS, which details about location of the data on the blocks and also which blocks are stored on which node. So this file is used by the name node when it is started. And edit log is a edit log. It records every change that takes place since the last snapshot. This is the importance of these two files, as it stores RAM as well as in hard disk. If in case of the system restart happens, at that time the details will be lost from the RAM, but it can be restored from the, it can be read from the hard disk. So that's why it is maintained in both the locations. And so as we had seen how the data will be partitioned when some job is submitted from the HDFS client to the Hadoop. So here data will be partitioned across different data nodes, and here the partition data in various data nodes will be processed, and which will be processed with map and reduce phases with various transformations. So finally the output of reducers will be combined and sent back to the name node and finally the HDFS client, as we had seen here in the first diagram. This is how we get the response. But when it comes to Hadoop 1.0 architecture, we have disadvantages. There are mainly two, which are, in case of name node failure, secondary name node restores the latest checkpoint snapshot and last transaction details would be lost after the checkpoint. This is the main drawback. And Hadoop 1.5 supports only 4000 data nodes in the cluster. So this would be overcome in Hadoop 2.0 architecture. So thanks for watching. Like, share and subscribe to ELE Prasad Tech Journal.